NASA has just detected something intriguing in the most recent data regarding the interstellar visitor 3I/Atlas. Honestly, the revelations are making it abundantly clear that this object is far from finished with whatever processes it's undergoing right now. I know many individuals were hoping that by this point in the narrative, things would be straightforward. Imagine it. It flared up, made it through its close encounter with the sun, and is now just quietly drifting into the abyss. That would certainly be neat and uncomplicated. However, the update that arrived today indicates quite the opposite. 3I/Atlas is still undergoing changes. It's still in a state of evolution. If you've been joining me on this incredible journey, observing this object from another star system navigate our little slice of the universe, you definitely don't want to miss what's about to unfold. Today's observations from NASA might be signaling the most compelling indication yet that this comet has not reached the end of its transformation. We are right in the midst of it, and the future trajectory remains uncertain. So, let me guide you through what they just uncovered because it's genuinely astonishing. Before we proceed, if this piques your interest, feel free to subscribe, turn on notifications, and like this video whenever you want. For the best experience, switch to full screen and prepare for what's coming up next. The observations taken today were not intended to be particularly dramatic. It was merely another routine, coordinated observational run. Ground-based telescopes and a few deep space cameras were aligned, aimed at this object simultaneously to gather yet another data slice for the timeline, right? Just standard procedure. The images were taken, stacked, and compared with prior observations from the day before. That's pretty standard at this point in the mission. However, once the teams aligned yesterday's stack with today's, upon closely examining the inner coma, the luminous cloud of gas and dust surrounding the nucleus, they noticed something very different from their expectations. In the images from yesterday, the glow surrounding the nucleus appeared relatively familiar for this comet. Sure, it was elongated and a bit twisted, but the primary axis of brightness was still evident. Essentially, there was one prominent bar of light extending into the tail. You could easily look at it and say, okay, that makes sense. It has looked this way for some time. But today's stacked image, that bar has vanished entirely. Instead, what they now observe is that the inner coma has taken on a layered, almost shell-like formation. Let me stress this. It's not the neat, clean donut shapes observed earlier in the encounter when it was nearer the sun. No, this is quite different. This time, it resembles a series of overlapping arcs, as if someone traced faint curved ribs through the glowing inner region around the nucleus. One arc is tight and bright, positioned very close to the core, another is fainter and a bit farther out, and a third is barely perceptible, stretching even further into the coma, tilted at a slightly different angle than the others. And that right there is your first major indication that 3I/Atlas is still actively evolving. These arcs aren't random. They aren't mere quirks in how we perceive it or simple artifacts from image processing. They represent snapshots of past activities, waves of material propelled from the nucleus in distinct bursts at various times, now fixed in place as these expanding shells radiating out into space. The emergence of a new inner arc since the last observation, literally since yesterday, indicates that something within this comet has changed again. And it occurred recently enough for us to witness the footprint of that change in real time. Consider that for a moment. This isn't ancient history. It's happening right now. Something inside this nucleus shifted within the last day or so, ejecting a fresh wave of material readily apparent as this new bright arc. Next, let's discuss the light curve, which adds another layer of intrigue. The light curve merely tracks the comet's brightness over time as it rotates. The brightness pattern recorded yesterday over one complete rotation already appeared complex. It wasn't a smooth, simple curve. It contained multiple peaks, slight shifts in timing, and hints of different active regions on the surface vying for dominance, each influencing the overall brightness as the comet rotated. However, today, when NASA's team examined the new photometry data and overlaid it onto the prior rotation period to see how they aligned, two immediate observations jumped out at them. First, the rotation period has slightly shifted again. It's a minimal change, just a minor shortening of the period, yet sufficient that the peak brightness now arrives earlier than anticipated if the spin were completely stable. The comet is rotating just a tad faster than it was before. Secondly, those smaller secondary peaks in the brightness curve have merged into a more complex plateau. Instead of distinct separate peaks, they now overlap, forming a more intricate pattern. So instead of a nice, clear rhythm of bright, then dim, Then bright again, the comet now exhibits a more jagged, irregular pulse, almost as if it's running on 2 or 3 different tempos simultaneously rather than a single steady beat. This pattern aligns perfectly with what you would expect when 2 events are occurring concurrently. First, the spin state of the comet remains in flux and is not yet locked in, and second, new vents are activating while older ones fade away. In other words, the comet's rotation and its activity pattern are still evolving together, interconnected, both undergoing shifts. When we bring spectra into the discussion, the picture becomes even clearer. Spectra provide measurements of specific wavelengths of light emitted by the gas surrounding the comet, revealing the types of molecules present in the coma. The new spectral data collected today demonstrate a subtle yet significant shift in the balance of different chemical species around 3I/Atlas. Some of the lighter, more volatile components, the ones that easily evaporate, which dominated the spectrum when the comet was closer to perihelion, are starting to diminish. Concurrently, the signatures linked with deeper, more refractory ices, the components that are harder to evaporate as well as larger dust grains, are becoming relatively stronger in the spectrum. This indicates that the outer coma is beginning to appear older, dominated by processed dust drifting away from the nucleus, while the inner region, situated near the core, is becoming enriched with fresh material that wasn't present just a week ago, newly exposed and released. This aligns perfectly with what you would anticipate if the thermal wave from the comet's closest solar approach continues to advance inward through the nucleus, progressively working its way deeper, activating layers that have never been exposed to sunlight before, layers that have never vented in this comet's entire existence. So when we synthesize all that information and examine the overall picture, what do we observe? New inner arcs emerging in the coma structure, a rotation period that's becoming slightly faster and more complex, and a gas and dust mixture that keeps favoring previously hidden material now being activated. 3I/Atlas isn't merely cooling off and settling after its close solar encounter. That's not the situation at all. It's peeling back layers one after the other. Here's what heightens the significance. Each layer that activates doesn't just enhance the existing behavior. It doesn't merely make the comet a bit brighter or add more material to the tail. It fundamentally alters the behavior. New fractures emerge on the surface, jets commence from new locations that weren't previously active, and the balance of gas and dust shifts, affecting the entire coma's visual appearance and how efficiently sunlight can exert pressure, creating what we refer to as radiation pressure. This leads us to the dynamics, the orbital mechanics, the critical aspect of understanding what might happen next. When NASA's orbit determination teams processed today's astrometry measurements through their trajectory solver, hoping to pinpoint where this comet is and where it's headed, they anticipated that the non-gravitational force would start to decrease in a clean and predictable manner. This non-gravitational force acts like a tiny rocket engine effect stemming from the jets. When gas escapes the comet's surface, it doesn't just brighten the comet. It pushes against the nucleus like a tiny thruster, affecting its orbit in ways that pure gravity cannot account for. The hope was that, by now, the force would stabilize, becoming weaker and more predictable as the comet distanced itself from the sun and activity decreased naturally. However, the magnitude of that force has remained nearly constant. It hasn't dropped off as expected. While the direction of the force didn't fluctuate as erratically as on some previous days, a positive sign, it still needed adjustments in their models to align the data accurately. The message from those figures is quite straightforward. 3I/Atlas is continuing to navigate through space actively. It's not as chaotic as it was during peak activity, but it's still sufficiently energetic that you cannot simply treat this comet as a passive rock succumbing to the sun's gravitational reach. The dynamics are more intricate than that. Within this nucleus, vents keep alternating states, and torque is still affecting the object, altering its spin. Here's where the term evolving moves from a neutral description to something resembling a warning. Think about it. A stable comet might flare up when nearing the sun, but then it settles into a calm, predictable decline as it retreats into the cold outer solar system. You can model it, predict its path, and essentially say, okay, we understand this object. However, an evolving comet, especially one originating from a different star system, with an internal structure and composition that remains entirely unfamiliar to us from previous experience, is in a state of constant reconfiguration. It's not stable. Changes are ongoing. Each time a new vent activates, it alters the stress distribution within the nucleus. Forces get redistributed. Weak areas that were once under compression might suddenly transition to tension and vice versa. Every small increase in spin rate, each time the rotation accelerates even slightly, adjusts how centrifugal forces act on weak regions in the structure. It's akin to spinning an object faster and faster until the forces overpower the material's strength. Each new layer of activity, each time a deeper layer activates and begins venting, adds pressure to a body that's already been stretched and stressed from months of heating and cooling cycles, expansion, and contraction during its journey through the inner solar system. So here is our current status. We've not yet reached the stage where we can confidently state that this object is breaking apart. Such a claim isn't supported by the data at this moment. However, the emerging picture from today's findings, drawn from various lines of evidence pointing in similar directions, suggests that 3I/Atlas is still transitioning. It's not in its final state. It hasn't settled down yet, but it also isn't in the initial state anymore. It's somewhere in the midst of an internal reconfiguration, a transformation kicked off by its sole close encounter with our solar system. From this point, two primary outcomes are possible. If, over the next few days, the arcs visible in the coma start to smooth out and become less distinct, if the rotation period stabilizes and ceases to drift, and if the non-gravitational forces from the jets start to decline predictably, we may witness this comet transitioning into a quieter, final configuration. It would be marked but ultimately intact after the experience, drifting back out of our solar system and returning to interstellar space, carrying the evidence of its visit with it. Conversely, if we observe new shells forming in the inner coma in the coming observations, if the spin drift persists and the rotation continues to vary, and if the jets keep altering direction with the activity patterns becoming more intricate, then this period we're currently experiencing, the evolving phase, might represent the last stable stage before something more dramatic occurs. We could be witnessing the prelude to a breakup event, observing early signs of a nucleus stressed beyond its structural limits, beyond what it can handle. Regardless of which path this takes, we are witnessing something truly exceptional. This is not merely a routine observation campaign. It's not about ticking boxes on a mission checklist. We're not capturing a single snapshot of an interstellar comet, writing a paper, and shelving it. We are witnessing change. We are observing evolution unfolding in real time, with fresh data arriving daily that presents something new from the day prior. There has never been an occurrence quite like this. We've never had this continuous high-resolution insight into an interstellar visitor undergoing such transformation. Oumuamua, the first interstellar object we detected, was already on its way out by the time we spotted it. We caught glimpses and then it was gone. Borisov, the second, exhibited more comet-like characteristics, allowing for better observations, but it remained relatively stable and well-behaved. It didn't exhibit these changes. However, 3I/Atlas is granting us a front-row seat to a unique instance, an object from another stellar system with a completely unknown history, its composition and structure formed under conditions we can only speculate about, undergoing significant alteration due to its close solar pass. We get to observe this transformation day by day, observation by observation. We see how it reacts, how it alters, whether it adapts and survives or reaches a breaking point. That's what makes this so captivating. Every new data release is significant because we genuinely do not know what will occur next. We can formulate educated hypotheses, create models, and analyze past comet behaviors, but ultimately, this terrain is uncharted. So, if you want to discover how this story concludes, if you want to find out whether 3I/Atlas can complete this evolution without disintegrating, you need to stay tuned. Keep watching, keep following along, because the next observation could very well be the one that tilts the scales in either direction. This comet is still crafting its own story, and we're simply here to read it as it unfolds, one page at a time.